Let's take a look at perimeter, area, and volume changes in scale. Look at this rectangle. If the base is reduced fourfold, then which of the following statements about its area will be true? Okay, well, let's take a look. They're telling us it's a rectangle, and the base would be one of these sides. Remember, you call one the base and the other the height? That's the same thing as calling them length and width. So if we call one base and one height, when they say if the base is reduced fourfold, that means we're dividing one of the sides by 4, right? Reducing means it's getting smaller, and fourfold means by a factor of 4. So if you think about the original area for this rectangle would be base times height. The new area, after we reduce it fourfold, would be, well, this would be 1/4 of the base. So that would be, if our base is being divided by 4 or multiplied by 1/4, that would be 1/4 times the base times the height. So you can see the answer is going to be 1/4 the area of the old area. Now, if you weren't sure if working with the formula messed you up a little bit, another thing you could do is actually figure out the numbers. And you might want to do this the first 1 or 2 times to kind of convince yourself that it's true. And then from there, it might be a little easier to just look at the formula and say, okay, what do I think is going to happen here? So let's look at the original one for just a moment, just to prove our thought here, that it's going to be 1/4 of the new area will be 1/4 of the old area. If you look at the original rectangle, well, if I say area is base times height, that would be 7 times 4. Oh, I'm sorry, not 4. This is a 3 over here. 7 times 3, or 21. So our original area was 21 inches squared. The new area, after we reduce that height fourfold, well, if we take 1/4 times 7, that would be 7 over 4. And if we multiply it by 3, and I'm going to write that as 3 over 1 just to see what our fraction looks like, you can see that when you multiply straight across the top of the fraction and straight across the bottom, you're going to get, well, 7 times 3 is 21, and 4 times 1 is 4, so 21 over 4. Now, I can reduce that if I wanted to change the format, but hopefully you would agree that 21 divided by 4 is 1/4 of 21. So that confirms what we looked at with our formula. Look at this rectangle. If the side lengths are tripled, then which of the following statements about its area will be true? Okay, and we really have to read these questions carefully, because notice the last time it was only the base that they were changing, meaning only one of the side lengths, and of course the side opposite it, but not the height. Here they're saying side lengths, meaning both of them. So let's say we call this base times height again. So the original, and we're talking about area, so we're looking at the original area would be found by saying base times height. Well, if we took whatever the base is and multiplied it by 3, right, if we triple it, that would be 3 times, the new one is going to be 3 times whatever that base was, 3b. And if we also triple the height, that's going to be 3 times the new height. And notice you'd multiply these together. So 3 times 3 would give me 9. So it would be 9 times whatever the base and height are. So anytime you're tripling both sides of a rectangle, the area should be 9 times the old area. And again, if you wanted to really check it out and make sure, you could also use the numbers that they gave you, right? For the original rectangle, we could say, okay, well, we know the area, base times height, would be 9 times 5, which is 45. And of course, our units here are in millimeters, so the area is going to be in millimeters squared. Okay, well, let's see what would happen when we did the new area. The new area, well, we're tripling the side lengths. Tripling means multiply by 3. So the one that was 9 times 3, that's going to give us a base of 27. And then if we also triple the height, well, 5 times 3, that's going to give me a new height of 15. Okay, and if you multiply this out, 27 times 15, that gives me 405, and of course it's going to be in millimeters squared. Now, since that's a pretty big number, it might not be immediately obvious, so let's divide. Let's say our new area, 405, let's divide it by 45 to see how many times 45 goes into it. So 405 divided by 45, and it gives me 9. So that means our new area, again, confirming what we already thought, is going to be 9 times the area of the old area. Look at this rectangle. If the side lengths are reduced fourfold, then which of the following statements about the area will be true? Okay, so without doing the exact numbers this time, let's just take a look at our formula. The original, we're talking about the area of a rectangle. So the original rectangle would have the formula area is equal to, let's call one side the base and 1 times the height. And of course, they did give us side lengths, but without even using those for just a moment. The new one, well, when we reduce it fourfold, we saw this a minute ago, reducing it fourfold means dividing it by 4 or multiplying it by 1/4. So the base would be 1/4 of whatever b was. 1/4 of b, right? We're taking it and reducing it fourfolds. And the new height, since they said side lengths, right? They're doing that to both sides. The new height is going to be 1/4 of whatever the height was. And they did give us the numbers, but this works regardless of whether we know the numbers or not. And then we can say, okay, well, if I multiply these together, well, when I multiply 1/4 times 1/4, I would multiply straight across the top and straight across the bottom. So in the numerator or top, 1 times 1 would give me 1. In the denominator or bottom, 4 times 4 would give me 16. So I wind up with 1/16 the base times the height. Now, of course, if you wanted to know the exact numbers, I could plug the 9 and the 3 into my original and my new area, but I don't even need to figure out that the new area will be 1/16 of the old area, right? If we compare the two formulas here. Look at this rectangle. If the side lengths are quadrupled, then which of the following statements about its area will be true? Okay, so this time they're saying side lengths, so that means both of them. Quadrupled means to multiply it by 4, right? So times 4. Which of the following statements will be true? Okay, well, the original area, since they're talking about area, so we really have to read here carefully. The original area would be the base times the height. Now, if I'm keeping b and h, so for all of these problems, when I'm changing the formula, I'm assuming b and h stand for the same original number, right? In this case, 6 and 7. So if I take them and I multiply them by 4, well, my new base is going to be 4 times whatever the original one was, right? 4 times b, or you could also say like 4 times 6 here if we were using the numbers. And my new height, quadrupled, means it's going to be 4 times whatever the height was. You could also say 4 times 7 if you were using the numbers. And then see what happens. Well, 4 times 4 is 16, so it's going to be 16 times BH. So hopefully you can see that it's going to be 16 times bigger when I quadruple both of the sides, which should make sense. I'm multiplying each of the sides by 4, so when I multiply them together, I'm multiplying 4 times 4, or making it 16 times bigger. Look at this square. And actually, guys, let's be careful here. They're calling it a square, but it's not, because we have a side length of 4 meters and a side length of 8 meters. So I think they mean rectangle. Let's change that to rectangle just to be consistent here with our definitions. Look at the rectangle. If the side lengths are doubled, right, lengths, meaning both of them, or both the sides we know, meaning all 4, are doubled, then which of the following statements about its perimeter will be true? Okay, so notice this time they're talking about perimeter, not area. So the perimeter of any rectangle is 2 times the length plus 2 times the width, or adding up all 4 sides, right? Keeping in mind that there's 2 sides here that both have measurements of 8 meters, and there's 2 sides that both have measurements of 4. That's why we're multiplying it by 2. So if we double both of those, so this is the original formula. For my new formula, if I double both of those, you can see that I would say 2 times whatever 2L gave me, right? Doubled means multiply by 2, plus 2 times whatever 2W gave me. So I would wind up with 4 times the length plus 4 times the width. So if I really want to look at this, I want to compare this to what the 2L plus 2W was. Well, I doubled both numbers before I add them together. So another way to say that is 2 times 2L plus 2W. Right? Because if I distributed this out, 2 times L would give me 4L, and 2 times 2W would give me 4W. So I'm doubling the perimeter. Now, this one's a little bit confusing when we look at it that way with our formula. So let's just look at our numbers and confirm that. If that was a little bit like, what are you doing there? Then just think about your numbers. For my original perimeter, I'm going to say perimeter original, just to keep track of this. If I plugged in my numbers, I would say, okay, let's say one of these is the length and one of them is the width. I would say, okay, 2 times my side length of 4 plus 2 times my side length of 8. And then I would work that out and see what it gives me for my perimeter, right? So 2 times 4, that's going to give me 8, plus 2 times 8, that's going to give me 16. And if I add that together, I get a perimeter of 24. So my original rectangle has a perimeter of 24 meters. Now they're talking about doubling the side lengths. So doubling the side lengths means multiplying them by 2. So for my new one, I would say 2 times, well, if I double my side length of 4, right, 4 times 2 would give it a new length of 8. Plus 2 times the width. Okay, well, the width was 8. If I multiply that by 2, it gives me 16. So if you work this out, 2 times 8 is 16. 2 times 16 is 32. And then finally, we would add those together, 48. And this makes it a little easier to see, okay, well, 48 is 24 times 2. So I doubled my perimeter. Or the perimeter will be 2 times, the new perimeter will be 2 times of the old perimeter. Okay, again, they're saying look at this square, so let's just change that to rectangle. Look at this rectangle. If the side lengths are tripled, then which of the following statements about its perimeter will be true? Okay, well, let's think what happened in the last problem. In the last problem, we doubled both of the side lengths of our rectangle, and the new perimeter was twice the old perimeter. So this time, if I triple both the side lengths, it would make sense that the new perimeter would be 3 times the old perimeter. Look at this square. If the side lengths are halved, then which of the following statements about its area will be true? And again, this is not a square because they're telling us 9 feet by 2 feet, so this is a rectangle. Okay, if the side lengths are halved, then which of the following statements about its area will be true? Okay, well, for our original area, we would say length times width or base times height, however you want to call that. And if we half the sides, that would be 1/2 of whatever the original length was times 1/2 of whatever the original width was. And if I multiply 1/2 times 1/2, remember I go straight across the numerator or top and straight across the denominator or bottom. 1 times 1 gives me 1, 2 times 2 gives me 4. So I would get 1/4 times whatever the length and width gave me. And again, you could plug the numbers in here, 9 and 2, if you wanted to know the actual numbers. But this is enough information to tell me that the new area is 1/4 or 1/4 of the old area. Look at this cube. If the side lengths are doubled, then which of the following statements about its volume will be true? Okay, so let's think about volume of a cube. Volume of a cube would be length times width times height, or since all 3 sides are the same, we could also think of that as side cubed, right? The side length times the side length times the side length. Okay, so here, if we double each side, well, that means for my original one, I would say the side length times the side length times the side length, right? So that's the original cube. My new cube, whatever the side length was, in this case it's 5, but let's just use our formula because that would work for any number, means that each one is being doubled. So 2 times the original side length, and then we're cubing that. Or another way to think of this is 2 times the side length times 2 times the side length times 2 times the side length, right? Cubed means to multiply it out 3 times. So 2 times 2 gives me 4, times 2 again gives me 8, times whatever s cubed was. So notice the original one, our volume would be s to the 3rd power, and our new one, after we double each of the sides, we get 8 times s to the 3rd power. So the new volume will be 8 times that of the old volume. And again, since this one's a little different, since it's a volume question, let's look at that with our original numbers. If working with the formula feels a little tricky to you, you can say, well, my formula is to multiply length times width times height, or to multiply those 3 side lengths together. So my original one was 5 times 5 times 5. Okay, so if you multiply that out, 5 times 5 is 25, times 5 again gives me 125. So that was my original volume. If I were to double each of the sides, right? Well, 5 times 2 is 10, so that they would all become 10 now. I would say the volume of my new cube would be multiply those 3 sides of 10 together. 10 times 10 times 10, right? 10 times 10 gives me 100, times 10 again adds another 0, or 1,000. And then, of course, you could compare this and say, well, how many times does 125 go into 1,000? To figure that out, we could divide 1,000 divided by 125. And that gives me 8. So either way, whether you work with the formula or whether you plug in the numbers, either way, we can see we get the same thing. The new volume will be 8 times the old volume.